So in this problem we're told y, and we want to show that the relationship between the sum of the second derivative and the original function is that they're equal. It would be equal to sine of x. So we'll have to begin by finding the derivative of y. Since c1 is just a constant, the derivative of cosine x is negative sine x. So I have negative c1 sine x. C2 is just a constant, so I have the derivative of the sine of x, which is cosine x, so C2 cosine x. The derivative of negative 1/2 x cosine x will require the product rule, where negative 1/2 x is u and cosine x is v. So u prime is negative 1/2 times v, which is cosine x, plus u, which is negative 1/2 x, times v prime, which would be negative sine x. And so there's the second derivative. That's the first derivative. And I can clean this up a little bit. Negative c1 sine x plus c2 cosine x minus 1/2 cosine of x plus 1/2 x sine x. Now the second derivative, the derivative of sine x is cosine x, so I have negative c1 cosine x, and that cancels out nicely with my first term in the original function. The derivative of cosine x is negative sine x, so I'll have negative c2 sine x, which cancels out nicely with my second term in my original function. The derivative of negative 1/2 cosine x is positive 1/2 sine x, because the derivative of cosine is negative sine. Now I have to use the product rule again, where this is u and this is v. So I would have plus 1/2 sine of x, u prime, and v, plus u, which is 1/2 x, times the derivative of v, which is cosine x. So I've got u and v prime. Now when I add y and y double prime, c1 cosine x and negative c1 cosine x cancel out. c2 sine x and negative c2 sine x cancel out. I can see that negative 1/2 x cosine x and 1/2 x cosine x will also cancel out. So the only two terms I would have left are these two, and their sum is sine of x. So we've shown that y double prime plus y equals sine of x.